In this video, we'll be learning how to differentiate quotients of functions using the quotient rule for differentiation. Now, we're reminded of the formula here at the top, and we're told that if a function f of x equals to u of x divided by v of x, then its derivative, f dash of x, equals to u dash of x times v of x minus u of x times v dash of x, all of which is divided by v of x squared. So let's go ahead and see how we can use this formula with an example. Let's say we're given the following function. F of x equals to 2e of x over cosine of x. And we're asked to differentiate this function. Well, the first thing we can do here is we can define the numerator and the denominator as two separate functions. So let's say u of x equals to 2e of x, and v of x equals to cosine of x. So now that we've done this, we can clearly see that we can rewrite f of x as f of x equals to u of x over v of x. Now on top of that, we can differentiate u and v quite simply, and indeed their derivatives would be u dash of x equals to 2e of x, and v dash of x would equal to negative sine of x. So now that we've done all this, we can go ahead and use the quotient rule for differentiation and state that f dash of x equals to u dash of x times v of x minus u of x times v dash of x, and all of this would be over v of x squared. So all we have to do now is replace all of these functions by their values. Let's go ahead. We know that u dash of x is 2e of x, and v of x was cosine of x, minus u of x, which was 2e of x, times v dash of x, which is negative sine of x. And all of this divided by v of x squared, which is cosine of x squared. Now we can simplify the numerator a bit and say that this equals to 2e of x times cosine of x plus 2e of x times sine of x. And all of this is divided by cosine of x squared. Now we could stop here, but we could also go one step further and see that there's a common factor here on the numerator, which is 2e of x. So let's go ahead and state the final answer as f dash of x equals to 2e of x times cosine of x plus sine of x, all of which is divided by cosine of x squared. And there you go. We've just differentiated this function using the quotient rule. Let's look at one more example. Let's say we're given the function y equals to 3x squared plus x over x cubed plus 1. So again, we'll start by defining the numerator and the denominator as two separate functions. So we'll say let u of x equal to 3x squared plus x, and v of x equal to x cubed plus 1. Then we can rewrite this function as y equals to u of x over v of x. And once more, these functions u and v can be differentiated quite simply. We can see that u dash of x would equal to 6x plus 1, and v dash of x equals to 3x squared. Now that we've done all this, we can go ahead and use the quotient rule for differentiation and state that f dash of x equals to u dash of x v of x minus u of x v dash of x, all of which is divided by v of x squared. We now replace all of these functions by their expressions, leading us to 6x plus 1, be careful to use parentheses here, times x cubed plus 1 minus 3x squared plus x times 3x squared, all of which is divided by v of x squared, so that would be x cubed plus 1 squared. We now distribute across the numerator, leading us to 6x to the power of 4 plus 6x plus x cubed plus 1. And we now distribute the 3x squared term into the second parentheses, so I'll leave it as 9x to the power of 4 plus 3x cubed, all of which is divided by x cubed plus 1 squared. And finally, we open up the second parentheses, making sure to pay attention to the signs, which leads us to 6x to the power of 4 plus 6x plus x cubed plus 1 minus 9x to the power of 4 minus 3x cubed, all of which is divided by x cubed plus 1 squared. As a final step, we simplify the numerator as much as possible. We can see that we have 2x to the power of 4 terms, so simplifying those will lead us to negative 3x to the power of 4. We also have 2x cubed terms, so simplifying those leads us to negative 2x cubed, plus 6x plus 1, all of which is divided by x cubed plus 1 squared. And that's our final answer. And there we have it. That is how we can use the quotient rule to differentiate quotients of functions.